Welcome student. Today we want to go through practical for the section form 3 and maybe our candidate who might be awake for now. You are provided with the solid, any solid. In this case I've chosen the first letter of my name, Gabriel, that is G, to carry out the experiment and write observation and inference on it. So experiment number 1 is you place the spatula of solid G in a test tube, heat it gently and then strongly. Test the gas with litmus paper. So when you are told to test the gas with litmus paper, then you expect 3 observations. Number 1, red litmus paper turn blue. Then you say a basic gas is produced. Then blue litmus paper turn red, you say acidic gas produce. If both the red litmus paper and the blue litmus paper does not change, in this example, the red litmus paper remain red and the blue litmus paper remain blue. What do you write? You write neutral gas produced under inference. So if they are not changing, then it is tricky a little bit, but it will depend with the question. If they don't ask you to test the gas, then under inference, you can just say a stable salt present. A stable salt is a salt that does not decompose to produce gas. If they ask you to test the gas, then you have to tell us that the gas is neutral, so a neutral gas produced. If you continue heating strongly, then a colorless liquid condensed at the cooler part of the test tube or whichever tube you are using, then you tell us under inference that solid G is hydrated salt, or you say solid G contain water of crystallization. So when we are heating gently, we are testing the gas. When we are heating strongly, we are testing the hydration of the salt. Then the remaining portion, you can be told to put them in a test tube and add water and shake. Then you divide the solution into several portions depending on the question. So in this case, what do you observe? When you are dissolving, then you need to tell us whether it is soluble or insoluble salt, and you need us to tell us the color of the solution. For example, in this case, if solid G dissolve in water to form colorless solution. So if it dissolve to form colorless solution, then the copper ion, the iron, and iron 3 ion are normally absent. Those are the colored ion. They are absent if the solution is colorless. If they are blue, you tell us that it is copper. If it is green, you tell us that iron 2. If it is brown, you tell us that it is iron 3. Then again, you need to tell us that solid G is soluble solid. That is, it dissolves. So most students just normally write under observation, they just write form colorless solution. That statement is incomplete. You need to write solid G dissolves in water to form colorless solution. Then to the first portion of the solution, you are required to add sodium hydroxide dropwise. So when we are adding sodium hydroxide dropwise, then we expect white precipitate soluble or white precipitate insoluble. So in this case, I've given an example where if the observation is white precipitate insoluble in excess, then under inference, you tell us magnesium, calcium, barium present. Though barium is normally bringing issues because it doesn't normally, the reaction is not normally very visible. So it depends with the saturation of the soil of the solution. So it is magnesium, calcium, and barium present if it is insoluble in excess. And that one will also means that aluminium, zinc, and lead ions are absent. Then to the next portion, you are required to add aqueous ammonia until excess. So when we are adding aqueous ammonia, if on top there you had already eliminated aluminium, zinc, and lead, then we don't expect to see them in this inference. So no white precipitate formed. If no white precipitate formed with ammonia, then we can easily say that barium ion and calcium ion are present because they don't form white precipitate with ammonia. Since ammonia is a weak base and does not normally give enough hydrogen ion to react with barium and calcium ion. So if no white precipitate, then you can comfortably say that barium ion, calcium ion is present. But if you see a white precipitate with ammonia, then we can easily say magnesium present. Remember, if there is a white precipitate with ammonia, aluminium and lead also normally form a white precipitate insoluble, but you had already eliminated them up, so you don't write them down here. Then how now we may say that barium and calcium are present. How do we separate them now so that we get one of them? You separate them using flame test. So this flame test, you use glass rod. You can use glass rod where you dip it into the solution and burn on non-luminous flame. So if it is barium, if you see apple green flame, some people say that it is pale, but when I was reading those days when I was a student, I read apple green flame. So your teacher can confirm that. Most people normally say that it is pale green. But the book I read those days I was in school, it was written apple green flame. So if you see an apple green flame, that is barium present. If you see orange red flame sometimes is also known as brick red flame. So orange red flame, that is calcium. If there is no distinct color, then it is magnesium. So from there, maybe you can now see. Practical, you must always do and write what you are seeing with your own eyes. Good. Now we have tested for cation. We have tested for cation. We need now to test for anion. Anion now, maybe you are given to the third portion. You are given barium nitrate. Any that you are given, you just use it. So if you are given barium nitrate and you are seeing no white precipitate, then you can easily and comfortably say that sulfate ion, and carbonate ion absent, because they are the only ion that will form white precipitate with barium. So if you don't see a white precipitate, then they are absent. If you see a white precipitate, then they are present. If they are absent, now what do we have? Then we may now have either iodide or chloride, the group 7. So you can be told to add lead nitrate. So when they ask you to add lead nitrate, then we are testing chloride ion or iodide ion. If you see a yellow precipitate, then iodide ion present. If you see a white precipitate, which I've given as an example in this case, then chloride ion are present. That is how we do that question. It is normally in question 2, but you just read your paper and you will see what is asked. Always do the practical. Thank you. Let me now go to organic. Organic. Organic, maybe you are provided with another solid, any letter, depending on who is setting. If I'm the one setting the exam, then I will use the first letter of heaven, which is H. So you are provided with the solid H. You need to carry out experiment on it and write observation. So maybe the first thing you can be asked to describe, when we are describing a solid, then it is either, if it is white, either crystalline or powder. So we talk about the color, crystalline and powder. So you need color and texture, appearance, if it is crystals, if it is powder. So you can always know that. You just say what you are seeing with your eyes. So place half spatula of solid H and burn using a luminous flame. So maybe observation, this one we are testing, we normally test saturation or unsaturated. So solid H, observation, if it melts and burn with blue flame, blue non-sooty flame, that is the best observation. It melts and burn with blue non-sooty flame. Then we can say the double bond, the triple bond are absent, meaning we only have the single bond. If it melts and burn with the yellow sooty flame, then the double bond, the triple bond are present. That one you have just tested a few by burning. You can burn on a watch glass, on a spatula. You just follow instruction. Then maybe B, part B of that. Put the remaining solid H in a boiling tube and add water. Shake. So we are checking if it is soluble or not soluble. So observation there, we can say, if there is a table for observation there, then observation will be solid H dissolves in water to form a colorless solution. Under inference, what do you write? Polar. You say polar compound present, because there is polar that normally dissolve in water, which is also polar. If it doesn't dissolve, then we say non-polar compound present. Then if that table is there, depending on the question. Roman 2, if the first, you are maybe asked to test the first portion of the solution, because you are divided them into different portions, with a drop of potassium manganate 7 acidified, and maybe you can warm if it is required. So if the purple acidified potassium manganate 7 decolorizes or changes from purple to colorless, then you can say under inference that the double bond, the triple bond, and ROH are present. Remember, 3 of them are present. Then maybe to the second portion, you are required to test using acidified potassium dichromate 6 and warm. You normally warm so that the green color can appear well. So if the orange acidified potassium dichromate 7 changes to green, then we say ROH present. We are confirming what is up there. Then to the third portion, you are testing with bromine water. Bromine water, maybe you warm this, sometimes you warm them so that the observation is clear. The examiner will always tell you what you need to do. If they tell you to warm, you warm. If there's no warming, then you leave it that way. So if bromine water, what do we expect? Bromine water is normally yellow. So if the yellow bromine water decolorizes, then the double bond and the triple bond are present, and you write it very well, very well. So you must make sure that carbon has 4 bonds around it because it has 4 electrons delocalized. Then if it doesn't decolorize, then you will say that they are absent. So remember that bromine is not a strong oxidizing agent, so it is not used to test for ROH. So in this case, you avoid ROH because bromine is not a strong oxidizing agent. Good. Maybe you are told to do what? To test the next position using pH chart indicator. So anytime you are told to test for pH, then you need to give us values. So you need a pH chart where we have values from 1 up to 14. So you normally just give one value. Don't give a range. So if it is at 1, you say 1, you correspond. If it is 1, you just say pH 1. If it is 2, pH 2. If it is 3, pH 3. So if you have seen 1, 2, or 3, then that one under inference you say strongly acidic. If you have seen 4, then you say pH 4. If you have seen 5, you say 5. If you have seen 6, you say 6. Then that is weakly acidic. If you have seen 7 corresponding to color 7, then you say pH 7, and that one is neutral. Sorry, I have not included it here. If you see 8, 9, or 10, then that is weakly basic. If you see 11, 12, 13, and 14, then that one is strong base. Make sure you are just giving one value. Don't give us 1, 2, 3, or no, just one value. If it is 1, say pH 1. You will see there's colors. So you say maybe this color is color number 1, color number 2, color. There are numbers there. So if you see 3, then you just write pH 3. If you see 4, pH 4. If you see 5, pH 5. This is an experiment you have to do. And you have to see. So we want to wish you all the best if they are candidate inside. And for Form 3, let us keep on revising because next year you are the next people. So we'll continue revising. I'll be doing videos. Normally I'm very busy during the day, so I can be posting at night, so don't have to worry. Anytime we have to keep on. Education is my priority. As an aspirant, education is my number 1 agenda. And thank you for listening. May God guide you, and let us always work hard, because tomorrow can only be solved by those who work hard today. Thank you.